Lactose is a disaccharide sugar made of one block of galactose and one of glucose. It is a major carbohydrate found in milk and, due to its size, it's hard to be absorbed by our organism. That is where the enzyme lactase takes action. This enzyme is produced by our digestive system and it breaks lactose into galactose and glucose. These are monosaccharide sugars that can be easily absorbed by our small intestine. Lactose is one of the most important carbohydrates during our nursing period. However, as other carbohydrates are introduced to our diet, the lactase production decreases, leading to a lack of this enzyme in our organism. About 75% of people are losing their ability to produce this enzyme, leading to lactose intolerance. Lactose can also be an environmental problem if on wastewater streams. Given these reasons, lactose must be removed from dairy products and waste streams. But, how do we remove lactose from a medium?
It's gonna be legend. Wait for it. And I hope you're not lactose intolerant because the second half of that word is dairy. No. Legendary.
Lactose can be either removed by separation methods or by hydrolysis, that is, breaking down lactose. Hydrolysing lactose is the most efficient and easy method, and it uses the same enzyme as our organism to catalyze the reaction. Enzymes are very specific, so only lactose will react in this process. The specificity of the enzyme can be explained by the lock and key mechanism. This mechanism can be seen in the animation, where the active site of the enzyme will only bind with a molecule of lactose, as their shapes are complementary. Lactose-free milk is one of the best examples of the use of this bioprocess in industry. Enzymes are produced by every living organism. The main sources of lactase for industrial processes are fungus, yeast, and bacteria. Lactase is obtained in its soluble form. It can either be used in this form, or be mobilized in a solid support. The process is very simple and is similar for both methods. In a reactor, the product is introduced first. Then, lactase is introduced into the reactor, in order to react with the lactose. It is important to notice that there must be an agitator to provide a well-mixed medium. Also, temperature and pH are controlled during all the process. After a given amount of time, there is not much lactose left, so the product can be now removed. There are two things that can be noticed from the explained process. 1. The enzyme is not removed after the process, and 2. This is a batch process. These are true if using the enzyme in its soluble form. As the lactase used in the process is the same as the one we have in our organism, there is no need to remove it from the final product. The problem with using lactase in its soluble form is mainly economic. It becomes inviable to remove the enzyme once it is mixed with the product, so this enzyme is lost on every batch. Immobilized enzymes has the potential to be removed easily with a simple strainer, that way enabling its further reuse. Even though immobilizing the enzyme has a cost, it can become cheaper as you reuse it several times. Also, immobilized enzymes can be used in a continuous process, also allowing a cost reduction. A packed bed reactor, PBR, would be a good example. Although a simple process, removing lactose from dairy products is a very important process in industry, given that so many people have lactose intolerance and are not prepared to remove milk and other dairy products from their lives. If needed, the same process can be used for the removal of lactose from waste streams.